Right now, in parts of India, farmers are looking at a field of perfectly edible food and, well, deciding it's actually far more profitable to burn it in a car engine than to, put it on a dinner plate.
Yeah, which is a pretty wild concept to wrap your head around at first.
Right. I mean, welcome to today's deep dive. We're looking at a huge stack of strategic policy analysis covering India's highly ambitious uh, ethanol strategy.
Exactly.
Because what we're really examining here is a nation attempting to literally grow its way out of oil dependency. Like they are shifting the entire foundation of their energy security from, offshore oil rigs directly to local farm fields.
It's a massive structural pivot. When you look at the ongoing conflicts in West Asia and just the deep vulnerabilities we're seeing in global supply chains right now, there's this huge push towards strategic autonomy.
Yeah, that makes sense.
Right. And the policy frameworks we're analyzing today, they show a government that is desperately trying to build an energy ecosystem that is, well, resilient to those external shocks. Because every single drop of fuel produced domestically is a drop of imported crude oil they just no longer have to depend on.
Which completely alters their vulnerability to global geopolitics.
Entirely.
So to understand the mechanics of how they're actually pulling this off, we really need to look at what ethanol blending involves, like on a basic chemical level.
Right, getting into the science of it.
Yeah. At its core, it's just the process of mixing ethyl alcohol with regular petrol to create a blended motor fuel. And the ethanol itself is derived from fermenting sugars or starches.
Yeah, but reading through the scientific literature in our sources, you quickly realize that the source of those sugars, where you're getting them from, that changes everything.
It really does. The policy actually categorizes ethanol into four distinct generations, right? Based entirely on the feedstock.
Yes, and that generational framework is literally the key to understanding the entire policy trajectory. So we start with 1G, or first generation ethanol, and this one relies directly on food sources.
So we're talking about what? Sugarcane?
Sugarcane juice, molasses, corn, and even damaged food grains like rice or maize. It's by far the easiest to produce because the sugars are just, readily accessible for fermentation.
Right, but I mean, using actual food creates some pretty obvious problems, which pushes the science toward 2G, second generation.
Exactly.
And this generation shifts away from the edible parts of the plant, right? It targets agricultural waste. So rice straw, wheat straw, corn cobs. The technical term in the literature is lignocellulosic biomass.
Lignocellulosic. And that term basically explains the central engineering challenge here, because lignin acts like this really tough plant armor.
Plant armor?
Yeah, it's the structural polymer that makes plants stand upright. So to get to the fermentable sugars that are locked inside all that agricultural waste, you have to break down that armor first.
Oh, wow.
And you do that using intense heat, really harsh acids, or, specialized enzymes before the fermentation can even start. It is a vastly more complex chemical process than simply, crushing some sugarcane.
Which naturally leads researchers to look for feedstocks that just don't have that armor in the first place.
Right.
Bringing us to 3G, third generation ethanol. And this is derived from algae, which is wild.
It is.
What makes algae so fascinating in the sources is that it doesn't require arable farmland. You can grow it in wastewater or saline water, and it doubles its biomass incredibly fast.
So you get a really high energy yield per acre.
Exactly. Without competing with actual food crops for soil.
And then, we reach the really cutting edge tier, which is 4G, fourth generation ethanol. And this one completely bypasses agriculture altogether.
Wait, completely.
Completely. 4G utilizes genetically engineered microbes inside these massive industrial bioreactors. And these microbes are designed to literally eat captured carbon emissions.
Like exhaust from a factory.
Yeah, like exhaust gas from a steel mill. And through advanced microbial fermentation, they essentially just sweat out ethanol. It transforms industrial pollution directly into fuel.
That is incredible. Thinking about this whole evolution, it feels a bit like, kind of like mobile network generations, right?
How do you mean?
Well, just like our phones, 1G gets the job done, but it's super basic and really heavy on resources. It's clunky. And then 4G is just this futuristic leap that solves all the structural problems of the earlier versions.
That's actually a great analogy. The problem India faces right now, though, is that their current massive push is almost entirely reliant on 1G.
Oh, really?
Yeah, the infrastructure is firmly rooted in that first generation ethanol. But, to understand why they are moving so aggressively, even with just basic 1G technology, we have to look at the macroeconomic layer.
Right, the economics.
So the government's immediate target is to move from a 20% blend, what they call E20, to a 21% blend.
Okay, so just a 1% increase.
It sounds small, but at the sheer scale of India's daily fuel consumption, that single percentage point is a massive macroeconomic lever.
Well, because India imports roughly, what, 85% of its crude oil?
Exactly.
That is massive outflow of dollars every single day.
Exactly the issue. So by reducing that oil import bill even by a fraction, India slows the bleed of its foreign currency reserves. And this
Huh.
directly helps manage their current account deficit.
Right, basically ensuring the country isn't spending way more on global trade than it's actually earning.
Spot on. Keeping those funds domestic plays a really vital role in stabilizing the Indian rupee against the dollar.
And the domestic destination for those funds is what makes this such a huge tool for rural transformation.
Right.
Like, this is a massive aha moment for me reading the sources.
Oh, definitely.
The policy takes what was traditionally viewed as an agricultural food surplus and just reclassifies it as a strategic fuel resource.
It's a total paradigm shift.
Right. It establishes this guaranteed, highly remunerative market for farmers that goes way beyond their traditional food procurement channels.
It basically creates an entirely new rural economy. And when we factor in the eventual transition to 2G technology, it builds this whole circular bioeconomy. Like, consider the ongoing crisis of crop stubble burning in northern India.
Oh yeah, the smog that just blankets entire cities every year.
Exactly. If 2G plants can become fully operational, that stubble transforms from a waste product that gets burned into a profitable industrial feedstock. So the farmer gets paid for their waste, the pollution source is removed, and the nation gets domestic fuel.
A win-win-win.
Yeah. Furthermore, the climate data supporting this transition is really substantial. According to the NEIOG studies detailed in our sources, sugarcane-based ethanol reduces greenhouse gas emissions by 65% compared to standard fossil fuels.
Wow, 65%.
And maize-based ethanol cuts them by 50%.
I mean, those reductions are a massive step toward meeting their targets under the Paris Agreement.
They are.
And the sources point out that India is actually leveraging this success diplomatically, too. Through the Global Biofuel Alliance, they're exporting this entire policy framework as the, quote, India model.
Right, positioning themselves as a global leader.
Yeah, they're setting themselves up as the template for how emerging economies can navigate the transition away from fossil fuels while, boosting their own agricultural sectors at the same time.
And the strategic vision there is undeniably elegant. But the reality on the ground, specifically this heavy reliance on 1G crops, it introduces some really profound systemic vulnerabilities.
Right. Okay, let me play devil's advocate here for a second. Let's unpack this. We are basically relying on agriculture to power our cars. Doesn't tying our national fuel security directly to the weather, like the monsoon season and farm output, doesn't that create a whole new kind of vulnerability?
Oh, absolutely. This is the whole food versus fuel dilemma that the policy analysts are so concerned about. You have this situation where the government is offering highly favorable pricing policies, right? Just to ensure the distilleries have enough feedstock to make the ethanol.
Right.
But the unintended consequence of that market signal is that farmers are abandoning essential, nutritionally vital food crops.
Because they want to grow whatever grain the ethanol plants are buying.
Exactly, particularly maize. The incentive structure is totally skewed. If the procurement price for ethanol-bound maize offers a higher, more reliable profit margin than, say, wheat or pulses, the farmer will rationally choose maize.
Right, they're just following the money.
But on a national scale, that creates direct competition for arable land. You basically begin trading nutritional security for energy security.
Man, that is a scary trade-off.
Yeah.
And the strain isn't just on the soil either. It's heavily impacting the aquifers. I was reading the notes about sugarcane. It is a notoriously water-intensive crop.
Very water heavy.
Yet because of this lucrative ethanol market, it's being intensively cultivated in historically arid regions.
Yeah, and it accelerates an already existing groundwater crisis. Relying on a water-heavy crop in regions with already fragile water tables, it just places unsustainable stress on the ecosystem.
So you're draining essential aquifers to grow a crop, to blend into fuel, to save the environment.
Right. The ecological math simply does not add up in the long term. which is exactly why the policy documents really emphasize the desperate need to operationalize 2G ethanol.
But making that jump from 1G to 2G, like going from burning the furniture to burning the yard waste, is hitting a pretty severe technological wall right now. Our sources highlight some massive operational inefficiencies in the current second-generation plants.
And the main issue there just comes down to the consistency of the feedstock.
Right, because agricultural waste is not a standardized industrial input.
No, not at all. A bale of rice straw can vary wildly in its moisture content, its chemical composition, and even contamination from dirt and rocks, just depending on where and how it was harvested.
And earlier, you mentioned that lignocellulosic armor, the lignin.
Yeah, the tough part of the plant.
Right. Well, the pretreatment machinery required to strip that armor using acids and high heat is apparently incredibly sensitive. The sources note that the highly variable quality of the waste, combined with abrasive elements like silica, which is just naturally found in crop stubble, it's basically acting like sandpaper on the downstream treatment machinery.
Ouch.
Yeah. It's causing frequent breakdowns and just massive inefficiencies. The technology simply isn't robust enough yet to handle the sheer chaos of raw agricultural waste on a commercial scale.
And, even if we look past the technological hurdles of actually producing it, we run into this fascinating market failure sitting right in the middle of the supply chain.
Oh, the distillery disconnect.
Yes, the distillery disconnect. Currently, distillery production capabilities have scaled up significantly, right? Because they're buoyed by all these government incentives.
Okay.
But the actual procurement by the oil marketing companies, the OMCs, is lagging far, far behind.
Wait, but if the government mandates an E20 blend, why aren't the OMCs just buying every single drop of ethanol the distilleries produce?
Well, it comes down to really inflexible pricing frameworks and major infrastructure deficits. So the OMCs operate on rigid, centrally determined pricing formulas. Distilleries are geographically locked in these rural agricultural hubs, while the OMCs need the fuel delivered to localized depots scattered all across the country.
Oh, I see.
So the OMCs are super reluctant to absorb the steep, variable transportation costs required to move the ethanol from the rural plants all the way to their blending facilities.
That makes sense.
Furthermore, many OMC depots simply lack the specialized storage tank capacity to even take on massive influxes of ethanol all at once.
So you have these rural distilleries basically sitting on oceans of ethanol, unable to sell it because the transport math ruins the OMC's profit margins.
Exactly.
And the OMCs don't even have the tanks to hold it anyway.
Right. And that resulting structural surplus completely threatens the financial viability of the entire manufacturing sector. If the distilleries can't sell their product, their assets go underutilized, their profit margins vanish, and any future private investment into biofuel infrastructure just chills completely.
Wow. And that infrastructure deficit, it extends far beyond just the OMC storage depots. It reaches all the way to the consumer's driveway.
Yeah.
Because ethanol is fundamentally different from petrol. It's highly hygroscopic.
Hygroscopic, meaning it pulls water straight out of the atmosphere. Right?
It acts like a sponge. And here's where it gets really interesting for you as a listener. If you put high blend ethanol, like E20, into an older legacy car that wasn't built for it, you get this phenomenon called phase separation.
Phase separation.
Yeah. The ethanol absorbs moisture from the air and bonds with that water. And because water and ethanol are heavier than petrol, that mixture literally separates and sinks to the very bottom of your fuel tank.
Oh, no.
Yeah, so your engine then sucks up a water-ethanol mix instead of actual petrol, which causes stalling, severe rusting, corrosion of internal engine parts, and the degradation of rubber seals and fuel lines.
I mean, it poses a really significant mechanical threat. The older the vehicle, the more vulnerable it is to that hygroscopic degradation. So to implement a nationwide E20 mandate without completely destroying the country's legacy fleet, the automotive industry has to adapt really rapidly.
And the sources show they actually are doing that. The auto industry is developing flex fuel vehicles, or FFVs.
Right.
These are built from the ground up with corrosion-resistant fuel lines and engine mapping software specifically engineered to handle high ethanol blends.
Yeah.
Like, they are even testing the engineering boundaries for E21 and E27.
Which is great. The technological capacity exists, right? It makes Indian vehicles globally competitive. However, the regulatory environment is kind of suffocating their adoption.
How so?
Well, really harsh taxation policies apply to these flex fuel vehicles right now, making them significantly more expensive than just your standard internal combustion cars.
So there isn't a level playing field.
Exactly. If the tax code makes an FFV prohibitively expensive compared to, say, a heavily subsidized electric vehicle, the average consumer just isn't going to buy it.
And if the consumers aren't buying the cars, The OMCs have even less incentive to figure out their supply chain issues to provide the E20 fuel in the first place.
It's a vicious cycle, and that OMC supply chain issue is the final and perhaps most daunting logistical hurdle here.
Mhm.
We noted that distilleries are heavily concentrated in a few agricultural states, predominantly the sugarcane hubs,
Right.
but the mandate is for a nationwide rollout. You have to somehow move this fuel across a subcontinent.
And because of that same hygroscopic property, the moisture absorption we just talked about,
Yeah.
you cannot pump ethanol through standard petroleum pipelines.
Precisely. Multi-product pipelines are designed for oil. If you run high-blend ethanol through them, it acts as a solvent. It scours the pipes, picking up decades of impurities and absorbing water along the way.
So by the time it reaches the destination,
The fuel is totally contaminated and basically unusable.
meaning the entire nationwide distribution relies on specialized stainless steel road tankers and railway wagons.
Yes.
I mean, the capital expenditure required to build a parallel, moisture-proof logistics network just to transport millions of liters of ethanol via truck from a few central states to every corner of the country. It's absolutely staggering.
It is an infrastructure mountain, and when we calculate the actual energy required to scale that mountain, we uncover the hidden carbon costs of the entire enterprise.
Right.
We know ethanol burns cleaner than petrol, but the industrial distillation and pretreatment phases of bioethanol, especially boiling those massive vats of liquid, are incredibly energy intensive.
Right. So if the distillation plant is drawing its power from a local grid that's running on coal,
Exactly.
the net climate benefit of the green fuel shrinks dramatically.
Yeah.
You're literally burning coal to make the clean fuel. It eats into the very decarbonization goals the whole policy is designed to achieve.
Yeah. So looking at the entire framework, the strategic policy analysis presents a pretty clear synthesis here. India's ethanol strategy is an incredibly powerful multi-tool. It simultaneously addresses energy security, shifts the geopolitical balance of power regarding oil dependency, provides a massive economic boost to the rural agricultural sector, and serves as a cornerstone for climate strategy.
It really is a brilliant multi-tool.
Mm.
But it's a multi-tool with some dangerously sharp edges.
Mm.
The core tension we've unpacked today is that the current reliance on 1G crops creates a really destructive feedback loop.
It does.
It risks driving food inflation, threatening nutritional security, and exacerbating severe water scarcity in already fragile ecological zones.
Which is exactly why the conclusion drawn across all the policy material is that the ultimate success of this strategy hinges on aggressive evolution. The government simply must solve the downstream machinery bottlenecks that are plaguing the 2G plants.
And they have to restructure the OMC procurement pricing to clear that distillery disconnect.
Yes. And most importantly, they have to push research and funding heavily into 3G and 4G non-food biofuels. Transitioning away from the farm entirely, moving toward algae and captured industrial carbon is really the only way to build a genuinely resilient and environmentally sustainable energy future without compromising the food supply.
It's a massive, delicate balancing act of policy, emerging technology, and sheer geographic scale. As we wrap up this deep dive, I want to leave you with a final thought to mull over.
Let's hear it.
As nations increasingly engineer crops to fuel our daily commutes, we are forced to ask a really fundamental question regarding our resources. At what point does the cost of powering our vehicles begin to outpace the value of the food on our plates? When you fill up your tank next time, take a moment to look at the pump and wonder, did the fuel going into your car start its life in a high-tech laboratory or in a cornfield that used to feed a community?
A vital consideration for the future of global energy, honestly.
Truly, thanks for joining us on this deep dive.